My work is deeply rooted in sociology. That's my background, and I am mostly interested in how social networks operate and how they are structured and influenced by different societal forces. And I think this kind of approach that kind of takes social science theory and questions to heart and really try to advance them with data. This kind of approach that I like is quite relevant in this day and age of flooding data, big data, and social media data. So in the past 3 decades, we've been all experiencing just a flooding of data that became available to us. So just like back in the day when the telescope was first invented, people started just observing things and measuring things, the celestial bodies, and trying to make predictions about where the bodies will be at a given time, and so on. And after that kind of active prediction and just measurement kind of subsided, then came the time when people and scientists were really trying to understand the movement of the bodies and coming up with models and explanations that could be further used down the road for other purposes and for more discoveries. So I think we're, in data science, there's a lot of data mining going on, and it has been really powered by machine learning algorithms and advances in that area. And so now we're observing a lot. We're making really accurate predictions about people's behaviors, but we're at sort of a point where we want to understand better how these predictions work. So some of the keywords of the day are explainable AI. Some predictions might cause biases, so we want to understand algorithmic biases, how those come about, and those all kind of point towards understanding human behavior a little better. And that's how I kind of see my work. And this is an example of trying to kind of incorporate the social science questions and really creating a dialogue between the social sciences and data science. So what I'll be talking about today is the strength, relational strength of long-range social ties. And I'd like to start with this notion of social distance, right? If you imagine somebody who you know, the more sort of social overlap and context you have with that person, you are more likely to communicate with them often and maybe even emotionally feel closer. So on the left-hand side here, we have two people, the two red individuals who have a relationship, but they kind of share a lot of different contexts: school, occupation, and neighborhoods, and they have common friends or common acquaintances. So this is a nice proxy of how socially distant or close those two people are. On the right side, you have two people who do have a relationship, some kind of a relationship, but there's no overlap between them. So in some ways, these two people are socially distant. Now, in the 1970s, Mark Granovetter, a very famous sociologist, had this idea about the strength of weak ties. Before I get into that strength of weak ties hypothesis, he was making this really important assumption that proved to be very consequential over the decades. So his assumption was that the strength of a tie kind of declines as the social distance between the two people increase, right? And that's kind of understandable, commonsensical. The less overlap you have, the less interest you share with somebody, or the less you have to talk about with that person. And so you might not feel as strongly emotionally with that towards that person, and or you might not contact that person as frequently as you would with somebody who has more social overlap with you. So that's the strength of that. That's the assumption he was making. Tie strength declines with social distance. And he built this, this hypothesis based on that intuition or assumption that the strength of relational ties, or the strength of ties, tend to be weaker when for bridging ties, right? So just as we've looked at before, when two people have a lot more in common, they share third-party relationships in common, and so their relationship is stronger. But when you don't have that common friendships, your tie is kind of bridging long social distances, and therefore they also tend to be weak. But there are some strengths for having that kind of a relationally weak tie. And the first one is that, when you have a weak tie that bridges long social distances, you're able to tap into information that is not circulating in your immediate vicinity, in the social vicinity of your network. And so you have this vision advantage or information advantage that comes with these weak relational ties. And because these weak ties are also bridging ties, they, at a more macro level, they tend to integrate communities, right? They create shortcuts in the overall network that would, if it didn't exist, then information or rumors or behavioral changes would have to take a more indirect route, a longer route to reach the other end. And because these weak ties integrate communities, they also facilitate collective action. When you need a lot of people to act in unison or rally towards a cause. In other words, when there is a big collective action problem, these weak ties that bridge different communities can, to some extent, solve that collective action problem and facilitate collective action. Now, back to that assumption that Granovetter made. That strong ties tend to be, or weak ties tend to be bridging ties. This idea kind of developed into a trade-off view that that was very influential in different literatures regarding social capital. So again, you have the strong ties and the weak ties. When you think about the relational or social resources that one can draw from these ties, the strong ties have distinct advantages in terms of social support and solidarity. On the other hand, again, they don't really give you this information advantage, but the weak ties do. They are bridging ties, they provide non-redundant information, but maybe not so much solidarity or social support from those weak ties. In terms of information diffusion, strong ties are able to sustain high bandwidth of communication. And so there's just a lot of, the sheer volume of information is pretty high with strong ties. They're not necessarily non-redundant. There could be a lot of information that you already know about, but nevertheless, there's high volume. The weak ties, on the other hand, there's not a lot of volume in the exchange, but what does get exchanged tend to be more diverse and novel. In terms of behavioral contagion, strong ties can facilitate really high-cost behavioral changes, or when the cost is high, when the stakes are high, the strong ties are required to create these changes in people's behaviors. Or you can think of like participating in a revolution. It's a matter of life or death, right? It's a big high stakes. And you're only going to really participate if your trusted strong tie friends and really people you trust can convince you. So the strong ties are conducive to these high cost behavioral contagions. On the other hand, when the stakes are low, the weak ties can also affect behavioral contagion. Lastly, in terms of innovation, you can think of complex innovations and combinatorial innovations. The complex innovations are the ones where you need these, for example, researchers to really talk to each other and share tacit knowledge to come up with something that's truly innovative and new, right? So in that case, you really need to foster a good relationship, a strong relationship, to be able to really, exchange very tacit and subtle ideas, as well as kind of coordinating your activities when the innovation is really complex. So strong ties are more conducive in that case. But when the innovation is simple combinatorics, like, you're just mixing and matching things that have never been mixed and matched before, then the weak ties can be sufficient. So this is all to say that, that idea of strong ties or weak ties being bridging ties kind of developed into this trade-off view. Are there any questions up to this point? Feel free to leave your questions in the chat, or I don't know like what the settings are here, but I'd love to just make it more conversational if that's okay.
Yeah, you can also raise your hands if you have any questions.
Okay. So, Granovetter's idea, his initial publication of The Strength of Weak Ties was in 1973. And the last time I checked it, that article had almost 60,000 citations. That's like a home run for a social science article. And so after 50 years and 60,000 some citations later, why are we still delving into this? Well, the answer is that Granovetter's innovative idea and the subsequent research that kind of backed his assumptions and the effect of the strength of weak ties were really using data before the internet age, the vast majority of them. And back in the day when social network analysts tried to collect network data, they had to do it all in pencil and paper, right? And so, trying to list all the people in a given group or a neighborhood or a school, it's just prohibitively costly as you try to scale that kind of survey-based data collection effort. And so typically the data sets were confined to neighborhoods, a neighborhood or a company, a school, and so on. So the social distance that you could really measure was confined by the data requirement or the data constraints. You couldn't really measure the full range of social distances in networks. And so the question, arises, well, does this pattern that Mark Granovetter assumed and so many people have taken for granted, really hold up when you look at the global social network? So just to kind of recap, the prediction in the literature since Mark Granovetter was that tie strength tends to decrease with the social distance. But to give you a sneak peek, what I find with my collaborators, whom I forgot to mention at the beginning, Michael Macy and Joshua Blumenstock, we find that the picture is a little more nuanced and complicated. Tie strength does tend to decrease with social distance when we're talking about local distances that typically were measured in at the school level or neighborhood level at smaller scales, yes. But when we measure them in global or country level social networks, they show this surprising increase as social distance increases. So let me talk a little bit about the data. I collected Twitter data with this huge crawler back in 2014. It was basically a large-scale snowball sample that ended up covering about 158 million Twitter users worldwide in 240 countries. And I tried to get as many tweets as possible per user. So the limit was 3,200 tweets. Based on this large crawl, the corpus, I applied this user country classification algorithm to group the users into countries and constructed within country communication networks, namely mention networks. And I'll get into the details. So for trying to figure out where people are living, it's kind of hard to rely on the profile information that users provide. Like, in my own Twitter profile, my location is La La Land, and where is that, right? So people can just use free text to indicate where they are, and in many cases it's symbolic or it's just nonsensical, so we can't really just rely on that. So instead, we leverage the GPS locations of some users to classify the locations of those who don't have their GPSs turned on when they're tweeting. So, this method is basically relying on the fact that a lot of the Twitter communications with network neighbors are geographically bound, they're proximate. And so if we use that information or that fact, then we'll be able to infer the location of users who don't have a GPS, tweets in their timelines, but kind of guess their locations and infer their locations from their network neighbors. So here's an illustrative example. So we're trying to figure out where Jim is located. Jim has 5 friends: Rick, Fred, Mary, Sue, and Joe. And Fred, Mary, Sue, and Joe, we know their locations from their tweets. But we don't know Rick's location, and we don't know Jim's location. We want to figure out where Jim is located. So what we do is we try to guess among the locations of the friends, which location decreases or minimizes the sum of distances to all the other friends. So in this case, Sue's location minimizes the distances from to Fred, to Mary, and Joe. It's kind of in the middle among these other 3 friends. So we assign we assign Sue's location to Jim. So Jim is now kind of considered at Sue's location. And in the next step of the algorithm, we use that information. We treat Jim as having a known location, and use that information, propagate it to trying to guess Rick's location. So in this example, Rick has 2 other friends, and then there's Jim, and the second friend in the middle, it minimizes the distances to all the other friends, and therefore the algorithm would assign Rick the friend 2's location, and so on. So when we apply this algorithm, label propagation with gradient descent, it's fairly accurate. We get a median error distance of 14 kilometers. So half of the guesses that we get are within 14 kilometers of distance. And this is accurate at the city level, so it's kind of overkill when our sole objective is to classify users' country. So we use this method and classify the locations of all the users that we collected. And then based on the country labels that we obtain, we group them together and construct within country networks. And I have about 200 countries in total, but in this study, I only focus on these 8 based on Twitter penetration rate for one, only the countries that have relatively high Twitter penetration. And secondly, kind of trying to get some variation in terms of economic and cultural differences and characteristics. So we have US, Japan, all the way to Singapore, kind of sorted in terms of size. So these networks are constructed based on bidirected mention ties. It's not just like following relationships or friendships. It's more, based on behavior, right? So in this example, Kyle here is Kyle mentions Steve Strogatz, and at a later point, Steve Strogatz mentions Kyle. So there is a two-way, bidirected mentioning relationship between Kyle and Steven. And so we only retain those relationships and say, okay, there's a bidirected mentioning tie between them. And the tie strength in this case is 2, because we just add up all the mentions that are occurring in both ways, in both directions. Another data source is phone data. And again, this is at the country level. We have 3 different countries, one unnamed Western European country with 51 million subscribers. We have the phone data from call logs from Rwanda and Afghanistan. And in these 3 data sets, again, we construct bidirected networks, calling networks, where the tie strength is simply the sum of the call volumes in both directions. Okay, so that's the tie strength, and that's how we construct a network. What about social distance? We need to measure social distance. The most commonly and widely used measure of social distance or network distance is to count the number of common neighbors between 2 individuals who are connected. So here in all these examples from left to right, we're looking at the relationship between the 2 red nodes. The 2 red nodes. And all the common neighbors who are connecting the 2 red nodes indirectly. So, at the very left, far left, we have 3 common neighbors. Then there's the constellation with 2 common neighbors, and the dyad with only 1 common neighbor. And then beyond that, there are no common neighbors for the 3 on the right. There's also a measure called tie range, which was originally proposed by Mark Granovetter in his 1973 article, but has been largely forgotten for a couple of decades. An interesting side note, I had a chance to speak with Mark Granovetter 2 years ago about this paper. And he didn't recognize that he used this range measure in his original article. So because it hasn't been used for such a long time, I think he even forgot about it too. But it's very it's a very interesting measure, and I'd love to discuss why people may have forgotten about this measure altogether. But in this case, we're using the tie range measure. Tie range is, in other words, it's the second shortest path length between 2 individuals who are connected. So it's the number of intermediary ties that are required to go from one end to the other end of the tie if that tie did not exist, right? So to give you a concrete example, let's look at the far left tie. So, if you cut this tie between the 2 red nodes, can you see my cursor moving, or?
Yes, we can see that clearly.
Oh, okay.
Thank you.
So, thank you. So if you cut the tie between the 2 red nodes, the shortest path becomes 2. Right, you have to go through either this tie 1, 2, or this tie 1, 2. The minimum is 2. Same in this case, it's 2, 2. But then for these three on the right, when you cut the tie, in this case, it's 3, 4, and 5, and so on. So the two measures capture variation in different types of ties. We'll call the ones on the left embedded ties because they're embedded in these third-party neighbors. And the common neighbor measurement can capture the variation or differences for these embedded ties, but not for the bridging ties where there are no common neighbors. On the other hand, the tie range measure can capture the variation in the bridging ties, the non-embedded ties on the right, but not for those on the left, the embedded ties. So they can capture different regions. And arguably, the tie range measure is more suitable for measuring longer social distances, whereas the common neighbor measure gives more accurate measurements for close social distances. So let's jump into the results. The first thing I wanted to show was how rare these long-range ties are. So here you see two panels, the Twitter panel on the left and the phone data panel on the right. The y-axis is the probability of a tie. X-axis is the tie range. So it's just looking at the distribution of tie ranges. And you can see that the y-axis is on a log scale. So it's decreasing pretty quickly, almost exponentially. So by tie range 9 in the Twitter case, you see very few of them, and you don't even see any range 9 ties in the Rwanda call network. So they're very rare. Just wanted to highlight that first. Okay, so now let's look at the common neighbors measure of tie strength. The y-axis shows the tie strength for Twitter, which is the total number of mentions. On the right side, we have total call volume measured in seconds for the three telephone networks. And on the x-axis, you see this decline of common neighbors. It's decreasing, which again indicates increasing social distance. So for both the phone data and the Twitter data, tie strength is monotonically decreasing with social distance as measured by common neighbors, which is what Granovetter assumed a long time ago, and what a lot of social network analysts have taken for granted. So nothing special here. Let's look at the tie range then, the other measure of social distance. Again, the y-axes are the strength of the ties. And remember that tie range 2 is embedded ties. These are all the ties that have at least one common neighbor. And you can see that when you move from 2 to 3 in the Twitter data, the tie strength decreases quite a bit. Similar pattern for the phone data, although the decrease extends to range 4. So again, this is just kind of confirming what we've known so far and what we never really cared to question about. The surprise comes when you go beyond those points, the shorter tie ranges. Excuse me. There are some different patterns that you can see here, but at the very least, none of these are showing continued decrease in tie strength as tie range increases. They all kind of increase one way or another, and they're more pronounced in the Asian networks in the Twitter case, but for the phone networks, they're all very prominent. So this was a pretty big surprise for us when we first found this out.
So, Patrick,
sure.
Sorry, it's me. So do you have potential explanation about why in the Twitter data that Asian countries has more pronounced like a V shape kind of phenomenon. Do you have some explanation?
I didn't look into it very closely, and this is because you know, I would like to do some more textual analysis on this and see if the nature of the ties or what people are conversing on these really long range ties are, you know, different or similar to other countries. But I haven't gone to that point yet. That's certainly something I'd like to, you know, delve into a little more. My guess, if I had to make a guess, it would maybe have to do with you know, a cultural explanation, basically. You know, in China, there's this very strong emphasis on relationships and, you know, 关系 and how, you know, it kind of permeates through the entire social fabric. In Korea, so it's you know, by extension, you know, not extension, but with a similar kind of culture in Singapore or Korea or, you know, Japan, very culturally similar in some ways, share that kind of emphasis. And I'll you know, get back to this question once I talk about the mechanisms that I think that are driving these patterns. Okay. So just some terminology here. We're going to call these strong communication ties that span extremely long network distances measured by tie range as network wormholes. Some of you might know what wormholes are. They're theoretical passage through space-time that could create shortcuts for long journeys across the universe. And you know, basically they are shortcuts, they're bridges. And we're going to call them network wormholes, these long-range ties that are strong. Okay, so what can we learn about these network wormholes? Well, we have quite a bit of data to look at it from different angles. We're going to look at the network structure, the temporal patterns, the lexical patterns, and geospatial characteristics of these network wormholes. So first off, you know, these wormholes are typically, they consist of peripheral nodes in the sense that the nodes who form these wormholes are low degree. They don't have all that many neighbor friends or communication partners, either on Twitter or in the phone network. So here we have the degree, the average degree of the two nodes on a tie, and we plot that degree by range, and it shows that the degree tends to decrease. So these are nodes that are kind of in the periphery of the network. They're not very central in the network. So, you know, that's one characteristic that we found interesting. And later on, I'll talk about the implications of this for innovation research. When we look at the temporal patterns, what we did here was kind of categorize the calling ties. These are all from the European phone network. Because we have timestamps and when people called one another, we're able to differentiate ties based on the hours they call. So you can have work hour ties where all the calls are between 9 to 5, Monday through Friday, and all the rest, like, you know, calls that are made at night or during the weekends. And the idea is that, you know, still, well, maybe not so much for instant messaging, but at least with phone calls, there's this strong norm that you don't call your business partners or you know, colleagues after work hours, right? We feel that there's a sufficient signal here that we can kind of differentiate these ties based on the times they call. And you can see on the left side that the common neighbor, the call volume by a common neighbor, that, you know, in both cases, work hour ties and more sort of social ties, they both tend to decrease in call volume as common neighbors decrease, so as social distance increases. But for tie range, the pattern is much more prominent for the any-hour ties or the social ties. So this increase in tie strength as tie range increases is largely driven by the social ties rather than the business hour ties. Kind of, you know, supplementing that, we looked at the word counts in Twitter using Luke, and we found an increasing proportion of social processes words in ties that had longer ranges. So, for example, buddy, friend, mom, boy, and all these social relational words tend to appear more often, higher frequency in longer tie ranges. So this is, again, kind of hinting at these long-range ties are social ties. And the flip side is that there's less work-related words that you find in these really long-range ties. What about geography? Maybe the long ties, long-range ties, are simply capturing geographically distant ties. That's one possibility, and that could just, you know, be a proxy for geographic distance. And so what we do here is we control for geographic distance and plot the same relationship, this, you know, strength by tie range, but kind of bin them into quintiles here. And so for all 8 Twitter graphs, Twitter networks, we still see this increase in tie strength as range increases, even after controlling for geographic distance. Same story with the phone network. And it's a little more pronounced here with the phone network. So then the question arises, okay, we found these wormholes, that's cool. And, you know, people didn't really think about this in the past, so that's cool, but do they really matter? And if they do, for what? One area that we wanted to look into was how these wormholes, they're very rare, as I pointed out, can they have an effect in facilitating or dampening social diffusion? So we employ these agent-based stimulation models to look at how social diffusion processes, the speed and the breadth of diffusion change or not change with and without these network wormholes. So I showed you these 8 different Twitter countries. I took the smallest country, Singapore, for this experiment. So we have the observed network with all the ties, and this picture shows those ties breaking down into roughly, you know, language groups, but they're network communities. And we're going to, you know, start these diffusion processes, simulations on this observed network, right? So nothing has changed. The ties are as they were observed in the first place. So in the manipulated condition, or in the treatment condition, we're going to artificially remove the wormholes. So how we do that is we want to keep everything else the same. So we're not like just deleting the ties, but we're randomly shuffling the strengths of all these ties so that the distribution of tie strengths follow what Granovetter and others may have thought about, how they looked at it. So tie strength monotonically decreases with tie range. So when you compare the speed and the breadth of diffusions across these different conditions, First off, the speed, you get faster diffusion with the wormholes, and the breadth of diffusion at equilibrium is much broader in the observed condition where you preserve the wormholes. So in short, the wormholes can facilitate diffusion. Here's a quick summary. I won't delve into them. It's just basically summarizing what we've been talking about. I think these wormholes have pretty interesting theoretical implications. First of all, that trade-off view of social capital needs some revision, right? It's not bridging versus bonding social capital. In some cases, you can have bridging and bonding social capital. You can have a friendship that is pretty strong, so you're receiving a lot of information, but because the social distance or the network distance is long, you're also tapping into novel information in high volume. And then there's this implication for innovations coming from the periphery. So there's this debate, or two camps in innovations research. Where do innovations come from? Do they come from the center, where very well connected people tend to be the locus or the focus of innovation, or do these mavericks or contrarians on the periphery tend to come up with new ideas and create something new and innovative? Well, these wormholes suggest that it's possible. The latter is it kind of supports the latter idea, that you have these people who are not very well connected in terms of the number of people they're connected to, but they can have these really long connections that allow them to come up with really innovative ideas. So future direction, I've been talking a lot about how these wormholes look like and what their sort of text-based or geographic-based characteristics are, but we really don't know how they come about. So one hypothesis is what I call the intimate strangers. You can meet somebody in transit, for example, out of a kind of a social vacuum, if you will, on a train, and you just instantly find this, you're drawn to that person, and you form this really strong relationship with that person in a very short period of time. You have no overlapping social context with that person, so it's kind of a bridging tie, but there's a relational strength in it. So that's one possibility. The other possibility is what I call tie stretching. And this there's an illustration here of this. Imagine that on the left side, you have these high school friends who are all, in this tightly knit group. And once they graduate, some will go to the West Coast for college, some will be in the East Coast, and some will just start working. And as time goes by, the weaker ties in that group will start to decay. And so the range of the tie starts to increase. And imagine 20 years later, the strongest tie remains intact, but all the neighboring ties that used to be there are no longer, they no longer exist. And therefore, you have a strong tie that is also long range.